Hey guys, so this was your homework question. So in this figure shown, there's a non-conducting disk. So this is a disk right now, whose mass is 2 kg and whose radius is 4 meters. On its upper and lower part of circumference, we have a plus q charge and minus q charge, right? So the thing to notice over here is we have charge only distributed on the circumference, right? And this plus q charge is distributed uniformly. This minus q charge is also distributed uniformly. This disk can freely rotate about a horizontal axis passing through point O. So basically, this disk can rotate about an axis which is passing through O. The axis is passing through O and perpendicular to the plane of the screen. So your disk can rotate either this way or this way, like in the plane. We have a uniform electric field which is in the vertical direction, and it's mentioned that QE value is equal to mg. So now this disk is rotated by a small angle. We'll see that it will perform SHM. We need to calculate what the time period of the SHM will be equal to, and the time period of the SHM is given in the form of under root of p pi by n, right? Okay, so let's go about solving this question. Okay, so if you already observed, this can be converted into a dipole because we have an equal positive and negative charge. So let's convert this into a dipole. The charge we have on the upper half is plus q, and your charge distribution is only there on the circumference, which means your charge distribution is like that of a semicircular ring. So you'll have to take the center of charge for a semicircular ring in this case, even though the object we have here is a disk. So here we'll have to say that your plus q charge is located at 2r by pi because your charge distribution was similar to that of a semicircular ring. Similarly, we'll have minus q charge also located at 2r by pi distance. So what will be a net dipole moment in this case? A dipole moment in this case then will become equal to q into 4r by pi. Okay, so now this is a dipole. And if you notice, this dipole is along the direction of electric field only. So this is right now in stable equilibrium position. So when we rotate this dipole by a small angle, if we know that this will undergo oscillation about its stable equilibrium position, and your time period for oscillation is given as 2 pi under root of I by p, right? So we just need to substitute all the values over here. So one thing to notice, we know torque is equal to, so when you rotate it by an angle theta, we know torque will be equal to P sine theta, and that will be written as I alpha, right? So this I is because of distribution of mass. So even though charge is distributed on the circumference, it is the entire disk which is rotating. It's the entire mass of the disk which is rotating. So the I value which we need to consider over here is for the I value of a disk only. So with that kept in mind, let's substitute values. So this will be 2 pi under root of mr squared by 2 divided by P, and P value was 4QR by pi into E, right? So simplifying this, we'll get 2 pi under root of mr squared by pi, mr squared pi by 8QRE. So 1R gets cancelled. QE was equal to mg, so m will get cancelled, and this pi, when it comes inside the square root, will become pi squared, which is equal to g, so this g will also get cancelled. So what we are left with is we are only left with 2 under root of pi r by 8, which is equal to nothing but under root of 4 pi r by 8. Substituting the value of r right now, r value is given as 4 meters. So I substitute r value as 4 meters, I get under root of 16 pi by 8, which is equal to under root of 2 pi. So this will be your time period, right? And your answer is given in the form of, this should be given, this root 2 pi is should be equal to under root of p pi by n. So that means p value is 2, n value is 1. So that implies p plus n will be equal to 3. Right? So this will be your answer for this question. See you guys in the next question.